right. So I have the worksheet here. It says Law of Conservation of Mass, Cookie Crumble Lab. What do you think about this lab? Can you predict what we're doing today?
I'm not sure.
You're not sure? Cookie crumble. Okay, first off, I want you to, because the objective is students will be able to, can you read the sentence?
Explain the law of conservation of mass and how it applies to chemical reactions.
All right, so this is about the law of conservation of mass, right? And the background is the law of conservation of mass tells you that matter is neither created nor destroyed. So neither means not, right? So this is matter, right? This is matter. It says it cannot be created nor destroyed. It is only conserved. So here we have two vocab terms. So can you read to me what reactants means and what products mean?
Reactants, the atoms you begin with, what is reacting?
Yeah.
Products, the atoms you end with, what is preceded.
What is produced?
Oh, produced.
So have you cooked before? Like, give me an example of a dish that you cooked before.
I don't know, tacos.
Or do you bake?
Mm-hmm.
So what are the reactants when you bake? What are the things that you begin with?
Eggs, flour, water,
oil,
and a pan.
and a pan. Okay, all the materials, right? And so those are the things that are reacting. And what is the product? What do you call the product?
The finished.
The finished product is called
A cake.
a cake, right? So that's pretty much it. So here's the problem. That in order for us to make sense of the law of conservation of mass. All right, so here is a question, and I want you to read the problem. Okay? So can you read to me the problem, please?
Imagine you have a whole cookie, break the cookie into tiny pieces and crumbs. How do you think the weight of the whole cookie compares to the total weight of the cookie crumbs?
Okay, so first off, answer the question, or what is your prediction? How do you think the weight of the whole cookie compare to the weight of the cookie crumbs? If you like cut this into pieces, right? It'll be called cookie crumbs. So what do you think?
I think the crumbs will be lighter than the weight of the whole cookie.
So you said the crumbs will be lighter, so can you write the answer there? So that's your prediction, right? The crumbs will be lighter, you said, than the weight of one whole cookie. All right, so why did you say that?
Because you're breaking it.
And
It's
so
going to be in small pieces.
if you break it, it's going to be in small pieces, but did you lose something?
No, but it's lighter.
So that's what we are supposed to do in this investigation, right? So I want you to use the scale and get the mass and write it here, the whole cookie crumb. And then, just put it there and then write the mass. Did I make a data table here? Okay, so first off, let me get a copy for myself. All right, so I have a copy here, and I can also scroll this down. All right, so here are actually the choices, right? Okay, so how do you think the weight of the whole cookie compares to the total weight of all the cookie crumbs? Circle the best answer. Okay, so let's just confine ourselves to the choices. So can you please read A?
The whole cookie weighs more than all of the cookie crumbs.
Will this be an answer?
No.
All right, so let's move on to B.
All of the cookie crumbs weigh more than the whole cookie.
Will this be an answer?
No.
All right, how about letter C?
The whole cookie and the amount of crumbs weigh the same.
So will this be your answer?
Yeah.
Okay, circle that. And then I want you to describe your thinking, provide an explanation for your answer. say it verbally first, and then once you finalize your answer, that's when you write it down. So why did you pick this one?
Because you're not taking anything away or adding anything.
I like that. I like that. You're not taking anything away or adding anything away. And in the first place, we're actually using the law of conservation of mass. What do you mean by conservation? Conserve. Have you heard of, like, Pia, turn off the lights so you can conserve energy?
Save.
Save, right? So this means that if you said you're not adding anything or taking anything away, then whatever mass you're starting with will be what?
Same.
The same, even if you cut this into pieces, like into crumbles. So what is that? Now we have to do the investigation. So 10.8, where are we putting that? Put it here. I have my, by the way, you know why we're using paper, right? I know that you prefer to use paper version than the online version. So mass of the whole cookie. So this is trial 1. Can you put it here? Trial 1.
On here.
Like here. Put trial 1, T1. And then measure this one for your trial 2, and then put it here, T2, and then put your cookie there. 10.6. And then put it here. All right, so third one. So I'll be very, very careful not to like drop a, what do you call this? Chocolate chip. All right, thank you. All right, so you're laughing. What is that laugh?
I'm so, I don't know.
Like, it's a laugh of like, what? Enjoyment. Okay, so first, before we proceed, can you do your hypothesis, like your guess? If I make the cookie crumble, then what? Will you still get the same mass, or I will get a different mass? Okay, so write it down here. Do you like cookies? Sometimes. Should have used ice. I think you like it better. Why not? Like, so the problem will, no, the problem will be different. Like, so let's use the 1 ice cube, right? Will it, when it melts, will it still be the same mass? That would be the question, right?
I don't know what
So with ice, same principle. Like, I have an ice cube, right? I have an ice cube, weigh it, let's say it's 10.6, and when it melts, will it still be the same? But I'll have a container for it, you know what I'm saying?
Yeah.
Because for sure, it's gonna go everywhere. So do you think it will be the same principle?
Yeah.
I need to hear.
Yeah.
Yes. Why or why not? Why? You're not adding or taking anything from it, right? It still is contained to wherever it is. But in that case, if we use ice, we'll use a container for that to contain it. Okay, so can you now, I hope you're feeling better now. I mean, you want some pancit?
Yes.
Oh, you know what? Yes. You know what?
Yes.
That will be a good news after this. Why? Because I still have a reservation in that.
So we can go together?
We can go together.
Oh, my mom, she wants to go to the Bible Museum.
Oh, I can give her the
She
ticket
wants to
for
go with
April,
you.
right? Because April is the deadline. Anyways,
Okay.
so what you need to do, let me give you, all right, here's how you do it, right? Quickly, I can make a container. How do I do this? I hope it doesn't last too long, but I'll make a container for your cookie crumble. Why am I making a container? Because I don't want it to just go everywhere, right?
Yeah.
Okay, so how are we going to do this? So do you know that you make the cookies crumble, right? And you put it in this container, and then you weigh it. Of course, you have to make sure that you add the mass of this paper boat.
Yeah.
Right?
You're making a boat?
I make not really a boat, but like a small box.
Oh.
And did you time it? Did you time?
No.
Did it take me a minute or so?
No.
Okay, here's
Who
my.
taught you how to make that?
I worked in a manufacturing lab before, but if I run out of
Oh
containers,
my
I
God.
make my own box.
Look.
How about that? Okay, so I want you to weigh that box over here. I want you to weigh that box so you know how much it weighs. So 4.7, maybe on the side. All right, so I want you to like make crumbles out of this cookie with your own hands.
How much?
Like, I don't know, like 2 pieces, whatever. So I'm doing the whole thing, so the grade goes to me. Okay, I'll let you do it. But make sure nothing goes away, right?
Okay.
It should be contained. All right, so this is your experiment. You're proving the law of conservation of mass. Anything that sticks to your hand, fingers, you have to make sure it goes there. So see, this is Pia's cookie crumble. All right, so let's mass it. What's the total? 15.5. Okay, so was this the first one? That was trial 1. Okay, so 15.5 minus 14.7. I mean minus 4.7. What's the, oh, calculator. Where's my calculator? Here, sorry.
It's okay.
We were just using a calculator earlier and I took it away. Okay, do your math. Of course, you're subtracting, right? 15.5 minus 10.8. What was your mass here?
10.8.
Wow, isn't it the same?
Yeah.
Congratulations, you proved the law of conservation of mass. All right, so are the masses equal or not? You said yes. Okay, so next one, I'm gonna, how do I get rid of this? Put it here and make sure, because I don't want to spend another minute to make R. So nothing in there, right? Okay, okay, take it away. Same mass, same mass. Okay. See, you're doing great. Okay, so remember the mass of the box is 4.7. Now what is the mass for this one? 15.2. Put it here. 15.2. Do you like this experiment?
Yeah.
Yeah, I like it. It's simple. It gives us the concept, the actual application. 15.2 minus 4.7. What did you get? 10.5. Oh, we're missing a few. Not exactly, right? Okay, that's why you want to do another trial. What happened there?
I don't know.
I don't know. So let's make sure that nothing is left there, okay? Right, that's experiment. Sometimes there's like, so sometimes there's human error, sometimes there's an error with the weighing scale. So let's make sure it's clean. Oh, you know what? Is there were some black spots over here that I got rid of. I'll keep it there. Okay. So, you know, all right, take it away. Still reading. 16.5. Can you put it there? 16.5 minus 4.7 equals 11. Oh, it's the same, yeah. Okay, congrats. Yes. Okay, so how will you, from the data you have gathered, provide an explanation of the results you gathered? Can you provide an explanation there? So, of course, it has to be based on the law of conservation of mass, right? Again, go to the first page of the intro, the background. What does the law of conservation of mass says?
Matter cannot be created or destroyed.
Yes, so what does that mean in your own words?
You can't add or take away from something.
Like
From math.
from whatever we have, that still stays the same. Even if we change the size, we change the,
Is she in there?
all right, we're leaving.
Come on, home,
Okay.
please.
Huh?
Yeah, tell me to go home, baby.